Hi, let us start with real numbers exercise 2.2 and question number 5 today. So without actual division, find which of the rational numbers have terminating decimal expansion. Actually, if they ask without actual division, we can directly divide and find it. But there is also another easier form. So before going to the question, let's see what is the trickier solution for that. The solution is if your rational number is p by q, which means if it is 2 by 16, can be expressed in the form of p by 2 power as something and m 5 power something, which means if you can write this as 2 by this 6 as to written in terms of 2 to the power. So if you are able to write the 16 or the number below in the terms of 2 to the power or also 5 to the power. If you can write it in this form, then that will be your terminating decimal. If you are not, if you get some, suppose you get something like 3 into some powers over here and 2 into some powers, that is not going to work. You should get only 2 and 5 powers. So with this quick recap, we are going to check our solution, how we write it. So the first question is, they were given is, let us start it. 7 divided by 128. So 7 divided by 128. Here our q is 128. We don't have to bother about this 7 as long as it is a natural number. So it is now 128. So 128. Let us try taking it in terms of 2. So 2 is 6 2s are 12 and 4 2s are 8. And now again 2 means 3 2s are 6 and 2 2s are 4. Now again 2 means 1 2 is 2, 6 2s are 12, and again 2 means 8 2s are 16, and again 2 means you will get 4 2s are 8, and again 2 means you will get 2 2s are 4. So how many 2s here? 1, 2, 3, 4, 5, 6. So you will get, and one more is here, 7 also, don't forget that. So this will be equal to 7 divided by 128. You can simply write it as 7 divided by 2 power 6. So you are able to express in terms of 2 power 6. So we can conclude this as a terminating decimal. Okay, but one quick question. We saw our question should be in form of 2 power something and into 3 power something, means let's write 2 or something here, and 5 power something should be there. But in this answer, we have got only 2 power 6. How can we say this is a terminating decimal? Because if 2 power 6 is there, that is fully enough. Because 5 power 0 can also be, we can write it as 5 power 0 also. So that is not the way. Either you should get 2 power 6 or 5 power 0. Both will work. So let us check our next solution. So the next one will be, have to write 21 divided by 15. So if you could see here, 21 divided by 15, let us take our 15. 15 means this can be written as 5 3s are 15. So we are going to write it as 21 divided by 5 into 3. But this is not of the form p by 2 into 5 powers. 2 power n or 3 power n, we have got a 3 here. So this strictly says that this is not a terminating decimal. So we can say this is a non-terminating and recurring decimal. Okay. So now let us move on to the next question. The third question is 4 9 by 35. So if you could see, this is a mixed fraction. Mixed fraction means we have got a number here. But my quick question is, do we need to change it to an improper fraction? Whatever we do, our numerator is alone going to change. Our denominator is not going to change at any cost. So even if you change it or don't change it, it is not going to affect it. So make clear of that point. But anyways, you need your rational number in the p by q form. So that's why it has changed it 45 and this will be 149. Okay. So anyways, let us take our 35 alone because we have to worry about the denominator alone. If you see 35, 35 is nothing but 7 5s are 35. So this is going to be in the form 7 into 5. But what we need? We need to 2 into 5 form. So again, we got a 7 here. This is not a terminating one. This is a non-terminating decimal. So please find it out whether your decimal is, your denominator is of the form 2 and 5 powers. So this is not terminating. Let's move on to the next one. Our next question is 219 divided by 2200. Okay, so it's a bigger stuff. So let's start dividing our 2200 by all the way. Let's start with 2. So 2 will be 1 2 is 2, 1 2 is 2, 0 0. Since we have got zeros at the ends, it's better we go with 5s first to make it quicker. 2 5s are 10 and 2 5s are 10 and a 0. Now again we got 2. So let us make it as 2, 1 1 0. Now again let's move on to 5. So 5 will be 2 5s are 10 and 2 5s are 10. Now if you could see, you can make it as 2 and this is 11. So now what we could do is we are getting 5, 5, 5. That is good. But we are getting 11 here. So this will be equal to 29 divided by 2 power how many 2's? 1, 2, 3 2's are there. So 2 power 3 into 5 power how many 2's are? 2 times 5. 5 power 2 into 11 is there. So 11 power 1. Oh God, this shouldn't be there, right? Even though you have got this, you have got an additional one. You shouldn't get an additional one. Either you should get in terms of 5 or 2 or both, but not any other number. So this is again going to be terminal or not terminating. No, this is non-terminating again. So please be clear. You should get 2 and 5 powers only in the bottom or either one of this. Okay, not others. Thank you for watching. Bye.